In this video, we're going to derive the xy coordinates for an angle of 60 and 30 degrees on the unit circle. So starting with our angle of 60 degrees, we're going to draw a perpendicular line down from our coordinates to the x-axis. And this is going to make our angle into a right triangle with our right angle here. And we're going to label the sides of this triangle. And so the adjacent side of this triangle will have a length of x, being the x component of our coordinate, and the height will be y, being the y component of our coordinate. Now the hypotenuse of this triangle is going to be a length of 1, as it is the radius of the unit circle, and by definition the radius of the unit circle is equal to 1. Now we're going to label these sides and angles into this triangle below, and so we have our angle of 60 degrees down here, and we have our hypotenuse of length 1, our opposite with y, and our adjacent with x. Now because of the sum of the angles in a triangle add up to 180 degrees, this angle here must be 30 degrees. And now what we're going to do is we're going to reflect this same triangle about this vertical height, and so this will be our hypotenuse, which is of length 1, and y stays the same and x gets reflected over here. And same thing with our angles, 60 degrees gets reflected down to this angle here, and this angle here will be 30 degrees. Now we're going to consider this outer triangle, and this will give us results that we can solve for x and y. So what we're going to do is we're going to redraw this triangle. So starting with our angles, this angle here will be 60 degrees. We'll have this angle being 60 degrees. And our final angle will be 30 plus 30, which gives us an outcome of 60 degrees again. And with our side lengths, we have 1, 1. So this side will be of length 1, which is the same as this side. And the base of our triangle is x plus x, which is 2x. Now notice here that all our angles in our triangle are equal to 60 degrees. And this means that we have an equilateral triangle. And a property of these types of triangles is that all the side lengths must also be equal. And so this side length here, the base of our triangle, must be equal to 1. And so we get an equation where we can solve for x now, and so we get x is equal to a half. So now that we've solved for our x component of our coordinate, we're going to consider our right triangle again. So this x value is equal to a half, and we're going to use the Pythagorean theorem to solve for our value of y. So by the Pythagorean theorem, we get the adjacent side squared plus the opposite side squared equals our hypotenuse squared. So the adjacent side is a half squared plus our opposite side y squared is equal to our hypotenuse 1 squared, which is just 1. So now we can simplify a bit, where we have 1 squared, which is just 1, divided by 2 squared, which is 4, plus y squared equals 1. And we can take this quarter over to the other side, and we get y squared is equal to 1 take 1 over 4. And we can change this 1 into 4 over 4, which is going to help us simplify. So we get 4 over 4 take 1 over 4, which equals 3 over 4. So now we have y squared is equal to 3 over 4, and we can square root both sides to isolate y, and we get y is equal to plus and take the square root of 3 divided by 4, which equals plus and take the square root of 3 divided by the square root of 4, which is 2. So our value for y is plus and take root 3 on 2. Now notice here on the unit circle that we are dealing with a positive value of y, as we are on the positive y-axis. So therefore we're only going to consider our positive solution for y, and so we get y is equal to positive root 3 on 2. So now we have successfully derived both our x and y components of our coordinates for an angle of 60 degrees on the unit circle. So rewriting our coordinates, we have our x component as a half, which we found down here, and our y component as positive root 3 on 2. And so let's rub this out to leave some room to interpret these coordinates in terms of sine, cosine, and tangent. In the cosine and sine rules playlist, we discovered that the coordinates on the circumference of the unit circle can be interpreted in terms of cosine and sine, as the x component is cosine of our angle, which is going to be 60 degrees in this case, and our y component will be sine of our angle, which is going to be sine of 60 degrees. And now by matching these two coordinates together, we can find cosine and sine of 60 degrees. So matching our x components together, we get cosine of 60 degrees is equal to a half, and sine of 60 degrees is equal to our y component, which is root 3 on 2. And now remember that tan is just the ratio of sine and cosine. And so tan of 60 degrees will equal sine of 60, which is going to be square root of 3 on 2, divided by cosine of 60, which is a half. And we can make this into a times by flipping this fraction over. And so we get root 3 on 2 times 2 divided by 1. And so we get tan of 60 is root 3 times 2 divided by 2 times 1, which is just 2. And these 2's cancel out, and we're left with tan of 60 degrees is equal to the square root of 3. Now we can also interpret these coordinates in terms of radian measure. And so, for example, we know that 60 degrees is pi on 3 radians. And so cos of pi on 3 radians will equal our x component, which is going to be 1 over 2. And sine of pi on 3 radians is going to equal our y component, which is root 3 on 2. And tan of pi on 3 radians is the ratio of sine and cosine of pi on 3, which is going to simplify into root 3 again. So now that we've interpreted our coordinates in terms of sine, cosine, and tangent of 60 degrees, we're going to move on to deriving the coordinates for an angle of 30 degrees on the unit circle. In order to find the coordinates at our angle of 30 degrees, we are going to stick to the same routine and first start by making this into a right triangle. So let's draw our vertical line. And we're going to consider this right triangle over here. So we already have our 30 degree angle marked in, and that means that this angle here must be 60 degrees, as the sum of the angles in a triangle have to add up to 180. And we know that our length here, the hypotenuse of our triangle, is going to be equal to 1, being the radius of the unit circle. And now we can start to consider our base and height of our triangle. So the base is going to be of length x, being the x component of our coordinate, and our height will be y, being the y component of our coordinate. Now I want you to consider this right triangle, but rotated 90 degrees. And I hope you can realize that it is the exact same triangle that we did earlier for our angle of 60 degrees on the unit circle. So let's redraw this triangle and try and match our x and y values to what we have here. Just earlier, we showed that this triangle with an angle of 60 degrees has a base of a half and a height of root 3 on 2. And if we consider the sum of the angles in this triangle, we know that this angle here must be 30 degrees, as 60 plus 30 plus 90 will give us 180 degrees. And because that this hypotenuse is of length 1, as it is the radius of the unit circle, and all the angles are the same, we know that these two triangles are equivalent. And so all we have to do is match the base and height and see what results we get for x and y at our angle of 30 degrees. And so if we consider our base, this is between our right angle and 60 degrees, and this is of length a half. And our right angle and 60 degrees is this height of our 30-degree triangle. And so this is going to equal a half. And that means that this side between our 30 and right angle, is root 3 on 2. Now we have our xy coordinates at our angle of 30 degrees. So the x component is root 3 on 2, and the y component is a half. And of course, let's relate this to our trigonometric values. So we know that cos of 30 degrees will be the x component of the coordinate on the unit circle at an angle of 30, which is going to be root 3 on 2. And sine of 30 degrees is going to equal our y component, which is a half. And tan of 30 degrees, well, that will be sine divided by cosine. So that's going to be 1 divided by 2 divided by our cosine, which is root 3 on 2. And we can flip the fraction and make it a times. So we get a half multiplied by 2 over the square root of 3. And you can see that these 2's cancel out, and we're left with 1 over root 3. And for completeness, let's leave our answer in the most simplest form by rationalizing the denominator. So we're going to times and divide by root 3 on 3. And this is going to be root 3 times 1, which is the square root of 3, divided by root 3 times root 3, which is root 3 squared, and the square roots cancel out, so it's equal to 3. And so we find that tan of 30 degrees is the square root of 3 over 3. And let's also consider these coordinates in terms of radians. So 30 degrees in radians is going to be pi on 6, and that means that cos of pi on 6 radians is going to be our x component, root 3 on 2, and sine of pi on 6 radians is our y component, which is a half, and tan of pi on 6 is going to equal our sine, a half, divided by our cosine, root 3 on 2, which is calculated here to be the square root of 3 divided by 3. So that's going to conclude this video, and in the past couple of videos we have slowly derived all the coordinates in the first quadrant of the unit circle. So what we're going to do in the next video is we're going to try use what we've learnt so far to find the coordinates in the other 3 quadrants.